Continuing our discussion of Linux heap overflows, we had overwritten our buffer here and we did something bad. Here is what should have been my buffer, these two lines, and I overwrote by another line. Notice what happened. I overwrote this last value. This shouldn't be surprising because this is my terminating null. And recall that all of these values are stored in little endian format. So where this used to be 3, 1, this is now 0, 0. So what's going to happen to me if I continue this program? It's going to become unhappy. It's going to give me a SIG abort and it says, you are a bad programmer. I've detected that you did something wrong. Now, it's interesting to note that it is pointing me at this address. It's not pointing me at the buffer before it. The programmer never sees this overhead. He never sees this line in between. So you might ask yourself, what if I overwrite this, but in a particular way? Can I get away with it? Let's try to put in what will at first seem like a strange value into this program. I'm going to say, instead of just running it with this value, I want to add the value of all f's. So I'll say XFF, 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 XFF. So that's 4 bytes, but we have a 64-bit system. So I'll do that 4 more times. XFF, 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 XFF. So hopefully that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, it is. Now we're going to do something that's going to seem a little bit strange. I am going to actually change this first byte to CF. Now, why would I do something like that? I'm changing this first byte to CF because I want to form something called the 2's complement of a number. Now, the 2's complement is something that is used when storing signed numbers. So if I want a negative number, I might want to point backward. Let's say I want to point by 48 bytes or hex 30. So I'm going to subtract that value from all f's and enter this value into my program and attempt to make this guy, the one that I just overwrote, make him negative. And what I'm trying to do is I'm trying to see if I can get the program to interpret that value to say, let me go back here. Because if I go back here, that's my happy place. Everything is okay here. It's just down here that I messed things up. So if I can do that, I might be able to do something bad to this program yet. Now, another thing, I can't input these kinds of values directly in GDB. So what I'm going to do is I'm going to run, and then I'm going to put in backticks Python, and then I'm going to give it a Python command. So I'm going to say Python-C, which says, I don't have a script file for you. Please just run this command. And then in single quotes, I'm going to say my command is print, and then in double quotes, all this stuff. I have to close my double quotes, close my single quotes, and close my backtick. So now I'm going to run this program, and it warns me. It says, are you sure you want to do that? Yes, I do, please. And I'm here before I've called malloc the second time. If I examine my memory, I see what I expect. So I have 3.1 here, and here's my second chunk, and it's 20FD1. Naturally, I would expect this to be decremented by the size of the next buffer. So I'll go ahead and continue. So I re-examine here, and sure enough, I have 3.1, 3.1, and this has been decremented. So it's now 2FA1 instead of D. What if we list our program? So we're right before our stir copy. Check our breakpoints. So I do have a breakpoint before the next line. So I'll go ahead and hit continue. Re-examine. And sure enough, I've overwritten this value with a 2's complement. What am I trying to do here again? I'm trying to get this to point back to this. Let's see if I've been successful at fooling this computer and its heap overflow protection. So let me go ahead and continue once again. And let's see what happens. Boom, sig abort. It says, hey, I tried to look in this next buffer and I wasn't happy. What that really meant is that I tried to look at this value, and this value did not make sense to me. So, in other words, no, it does not interpret that as a signed value. I can't put a negative value in there and expect to get away with it. We're going to take a brief break, and when we come back, we're going to continue this discussion of heap buffer overflows and see if there is a way, after all, for us to get around all of these protections.